Okay, this is part 2 of lesson 5-4 on solving compound inequalities. In this lesson, we're going to talk about or compound inequalities. In part 1 of 5-4, we talked about and inequalities. All right, so obviously, a compound inequality that's an or problem has the word or in it, and it will have the word or every single time. So you'll know it's an or problem, okay? There's actually 3 different types of or problems. So the ones I'm going to show you are actually how to graph them. We solve them all the same way, just how we graph them is different. So this first way is like the main way that you're going to see. And then there's 2 exceptions, okay? So this way, we're going to keep our smallest number on the left and our biggest number on the right, just like we did with and inequalities. Instead of writing this reversed, like -3 is greater than x, since it's not related to this guy, when they were and inequalities, we could write them all as one big inequality. So we wrote them together and we put x in the middle. But in this case, they're not really related. We just graph them on the same number line. That's the only way they're compound. So we're going to write this with the variable first, like you're supposed to traditionally anyways. Okay? So in an and compound inequality, x has to solve both inequalities at the same time. There's like one correct answer for x. And in or compound inequality, x is either going to solve one of them, or you have to show what x could be to solve the other, right? So we're graphing 2 different things here. Okay, so either x can be less than -3. So I put a circle on -3. There's no line under it, so I leave it open, and I'm going to shade less than -3. Or x can be greater or equal to 1. So I'm going to put a circle on 1. I'm going to shade it in since it has the line under it here. X could be 1. And I'm going to shade everything bigger, right? So and compound inequalities, we shaded in the middle, right? Whatever x was could solve both inequalities at the same time. In an or problem, it's either going to be x is either going to be one of these numbers or it's going to be one of these numbers. They're completely unrelated. They go in different directions, okay? So that's a traditional, normal, regular or problem. Then we have 2 exceptions. So I'm going to go over both of these. The first one, I'm doing a different color. And I'll put a big like asterisk on either side, right? This is an exception. Put a little box around it. Make it stand out. Okay, so the first one says x is greater than 4. Okay, so we put a circle on 4. And it doesn't have a line under it, so we leave it open and we shade to the right. Or, so these numbers solve this guy, or on the same number line, x is greater than -2. Remember, we always write our variable first. So I put the -2 here, and then my sign's open towards the x. So it has to stay open towards the x. So x is greater than -2. So I'm going to put a circle on -2, and I'm going to shade all of these numbers, right? So my number line should show all of the numbers that solve this guy or this guy, all of them, right? Every single number on here that solves this guy should be shaded, and every single number that solves this guy should be shaded, right? So instead of leaving this circle here, we're going to kind of simplify. When we get one of these that instead of going in 2 opposite directions, they go the same direction, we're going to just shade it one time. We're not even going to leave a little bubble right here. So we're actually going to put a circle on one of the numbers, and we're just going to shade everything. Right? Because, yeah, that was an open circle. 4 is not an answer to this inequality, but it is an answer to this inequality. And all of our answers in the shaded region have to solve this or this, right? We have to account for everything. So we had to end up shading over this open bubble. So then we just get rid of the bubble and show this is our answer. Final answer, okay? So we still shaded, this way went 2 opposite directions. These 2 both went the same direction, so we just gave it one big shading. And then for this one, put it in blue, we have x, here, I'll do a big, this is another exception. Boom, 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 make it stand out. Okay, so we've got x is less than or equal to 7. So I go here to 7, I shade it in because it's got the line under it. And I'm shading everything less than or equal to 7. And then this one says x is greater than 5. So I put an open circle on 5, and I shade everything greater than 5, right? Well, look, I've covered everything on my number line. Now, why isn't it like the and problems where all I shade is in between? Because in an or problem, x isn't solving both of these at the same time. Whatever we solve for x doesn't satisfy both inequalities. If that were the case, we would just be narrowed down to this, right? All these numbers, of all these numbers, only this part satisfies this stuff. And of all these numbers, only this overlapping part satisfies the other inequality. That would be an and problem. This is an or problem. So we're not combining anything. We're graphing all of one of the problems, and we're graphing all of the other, one of the solutions, and we're graphing all of the other solutions. So everything ends up getting shaded. So instead of leaving bubbles on, you don't need to leave them. You're just going to shade the entire number line. Every single number on your number line will solve either this inequality or it'll solve this inequality. All of these numbers will solve one or the other. Okay, so we're shading everything. So those are our 3 types of OR problems. This is your normal OR problem. And I'm like reluctant to even show you the others because this is the one we're focused on, right? And problem, shade in between, or problem, shade away. But then the exceptions are you might get 2 that go the same direction, or you might get 2 that go opposite directions, but they go the wrong way. Instead of away from each other, they cross each other. And if that's the case, you shade everything. Right? So don't go over something, because some people will see this and they'll go, oh, I'm supposed to leave an open circle there and this one's shaded in, so I'll need to shade everything this way and leave that open. And no, you don't leave anything open, because while this might not have the answer of 5, this one does. So every single number on the number line either solves this one or this one. Okay, I hope that helps. So let's do a few examples. We're going to kind of jump around a little bit. This is our OR study guide paper. I wanted to go over that before I jumped into this. So these are all OR problems. I'll highlight that here. Oh, nope, sorry, just kidding. That's the end. Grab the wrong one, sorry. That's the answer key. Pardon me while I get it together. Not even. Okay, so here is the 5-4 study guide. I just wanted to show you the other, how to solve everything before we got into this. So these are the OR problems. They give an example up here. They give you a compound inequality. It's an OR inequality. It has the word OR in it. All OR compound inequalities have the word OR. Remember, not all AND compound inequalities have the word AND. Some of them were just written out as one big 3-part inequality, no word AND. These will all have the word OR. All right, so they've separated them into this guy or this guy. So they've solved them separately. For this one, they got this answer. For this one, they got this answer. And they graphed them on 2 different lines to begin with to show you, right? So I can zoom in a little. All right, so for A is less than 5, they put an open circle on 5 and shaded everything less. For A is less than -1, they put an open circle on -1 and shaded everything that way. Well, think about it. If we put the 2 together, if we graphed this one here and shaded everything, this is one of those special cases, right, that everything gets shaded. So they end up just combining them, and this is the answer down here. This is how you would graph it on a number line. Just shade everything that's less than 5. Okay, kind of makes sense. And don't forget, if this is our answer, if A is less than 5 is our answer, then we have to draw this little line here, tell what our variable is. Duh, you can see it, right? And then put the little squiggles outside of it. Don't be afraid of this. I know it looks weird, but you're mainly just focused on this part. All right, so let's do a few of these. Use my red pen so it stands out. First of all, this first section has already been solved for us. We're just graphing the answer, right? So first, they're all OR problems. B is greater than 2, so I put an open circle, and I shade this direction. Or B is less than or equal to -3. So I shade in my circle, and I shade everything this way. Right? Easy enough. Easy peasy. Regular old or problem. Okay, for this one, this says 3 is greater than or equal to Q. Remember, you got to always put the variable first. It's open towards the 3, so I'm going to keep it open towards the 3. So Q is less than 3, so open, go this way. Or Q is less than or equal to 1. So I'd put a shaded in circle here. But I don't have to do that because I've already shaded, oh, not that one, that's -1. I've already shaded in 1 from the first part. This is one of those special cases where both answers go in the same direction. They don't go in opposite, they go the same. So I don't have to, once one is shaded, I don't have to put the bubble over the other one. I don't have to put a bubble over one because it's already shaded. Okay, go back to the notes if you forgot. Number 3, y is less than or equal to -4. Shade in a bubble on -4, shade to the left. Or y is bigger, greater than 0. So I put an open bubble on 0, no line under that inequality sign, and shade this way. Easy peasy, traditional or problem. Number 4, 4 is less than or equal to p, so I'm going to rewrite that as p greater than or equal to 4. Here the mouth is open towards the P, so I keep it here. So I'm going to shade in 4, the bubble over 4, and I'm going to shade everything to the right. And then P is less than 8. Doesn't even make sense because there's not an 8 on here. So if I went out here, 7, 8, I would do an open bubble. And I would shade everything this direction, right? So since I'm shading either everything this way or everything this way, this is one of those special cases where the entire number line gets shaded. Like we just went over on the bottom of those notes I just gave you. They overlap each other and go in opposite directions, so I shade everything. Everything on this number line is either going to solve this inequality or this one. All right, number 5, -3 is less than D, or D is less than 2. So I'm going to slip this right here, flip it. D and -3, the mouth is open towards the D. So this is saying D is greater than -3. It's going to go this way. Or D is less than 2. So I would do an open bubble here and go this way. Uh-oh, well, they overlap, right? So if everything this way is shaded and everything this way is shaded, it kind of cancels out these little open bubbles. So we end up just shading the entire number line again. You don't have to have those bubbles on there. Just shade over everything. If you're doing this in pencil, you can even erase those bubbles. You don't need them there once they've overlapped. Okay, and then number 6, I'm going to flip-flop this. X, -2, the mouth is open towards the X. And this one too. X and 3, the mouth is open towards the X. Got a line under it. Okay, so this is saying X is bigger than -2 or X is bigger than 3. Well, either way, it's going in this direction. We're shading all the numbers bigger than -2 and all the numbers bigger than 3. Well, if we shade all the numbers bigger than -2, that's all of these, right? We shade over -2. It has a line under it, so we shade it in. And then if we also shade all the numbers bigger than 3, we shade in the number 3 and we still shade to the right. So all numbers to the right get shaded. All numbers to the right of -2. Okay, that's another one of those special cases that they both go in the same direction, so you don't have to graph one of the bubbles. All right, let's do a little bit of math, solve some. I'm just going to do these 3. Then we'll do a quick review of and compound inequalities, more ors, and then we're done. All right, number 7, 3 is less than 3w, or 3w is greater than or equal to 9. So here, if we divide both sides by 3, we get 1 is less than w. In other words, w is greater than 1. Or if we divide both of these by 3, I get w is greater than or equal to 3. W is greater than or equal to 3. Okay, so w is greater than 1. Shade this way. W is greater than or equal to 3. I would shade all of that and shade this way as well. So I'm just going to shade all numbers to the right of 1 because that includes this 3 and everything bigger than it, right? This is one of those special cases where both answers go the same direction. So we only have one. It looks like we only have one answer graphed. Okay, number 9 here, right below it. 2x plus 4 is less than or equal to 6, or x is greater than or equal to 2x minus 4. So I'm going to solve both of these out here to the side. 2x plus 4 is less than or equal to 6, minus 4 on both sides. 2x is less than or equal to 2. Divide by 2. X is less than or equal to 1. So I'm going to circle and shade it in on the 1. And I'm going to shade in everything less than 1. To right on my graph, not above it, right on it. And then for the second part, x is greater than or equal to 2x minus 4. And then get rid of my smallest x, 0 to 1x, x minus 4, and then add 4. 4 is greater than or equal to x. In other words, x is less than or equal to 4. So I'm going to shade in the sky. Oh, look, it's another one of those special cases. Tons of those, right? So we just shade right on over that other bubble. And everything shaded positive 4 or less answers either this inequality or this inequality, right? And then last one, number 11. 1/2 n is greater than -2. If we were to solve that, -2, we're going to multiply both sides by their reciprocal. So flip it upside down. 2 over 1. Multiply this side by 2 over 1. These cancel, and I'm left with n. Now, I didn't multiply both sides by a negative. Yeah, this side is negative, but I didn't multiply both sides by a negative, so my sign does not change. And then -2 times 2 over 1 is -4. So n is greater than -4. All this gets shaded. Or, now I can solve this one. 2n minus 2 is less than 6 plus n. Get rid of the smallest n. N minus 2 is less than 6. Add 2. N is less than 8. Okay, well, we don't have an 8 on our number line, but if we did, we would have an open circle on 8, and we would shade everything to the left here. So how is that going to change what I already have? Well, all of these numbers to the left of 8 will get shaded. So this is one of those special cases where the entire number line gets shaded. Every number on the number line is either going to solve this inequality or this inequality. So we shade everything. Okay, hopefully that's making sense for you. All right, let's do a couple examples from both. Number 1. We're going to do x minus 4 is less than 3x plus 4 is less than 2x plus 7, less than or equal to 2x plus 7. Can you see that okay? Yes, you can. All right, so we're going to solve first, and then we're going to graph. So here, I'm actually going to, since this is kind of big and involved, and I can't just, whatever I do here, I got to do here, but it gets too cumbersome, I'm actually going to separate this. So I'm going to write this inequality over here. X minus 4 is less than 3x plus 4. And I'm going to write this inequality over here. 3x plus 4 is less than or equal to 2x plus 7. I think I can back up a little. Yeah, there we go. Okay, so I've just separated them out. Okay, I'm going to solve them, and then I'm going to put them back together. So here, I'm trying to get rid of the smallest x. So I subtract x from both sides, and I'm left with -4 is less than 2x plus 4. I need to get x alone, so I subtract 4, that's -8. Bring down my sign to x, and then divide both sides by 2. So -4 is less than x. Now, normally at this point, I would flip-flop these two, right? But I'm about to put it back together with this other answer in blue on the right, so I'm not going to flip-flop anything. Okay, so now I'm going to solve this side. Get rid of my smallest x, minus 2x on both sides of the inequality. That leaves me x plus 4 less than or equal to 7. And then I need to subtract 4 from both sides. X is less than or equal to 3. All right, so I've got this answer and I've got this answer. Now I want to put them back together. So see how x is here and x is here? I'm just going to write it one time in the middle. And I'm going to write this side here, -4 less than. And I'm going to write this side here, less than or equal to 3. Right? So I've got this answer from here and I've got this answer here, but now they're all put together. So this is my solution, and then once I graph it on my number line, I don't have to draw an entire number line. Smallest number's on the left, so I gotta have that number. Biggest number's on the right, so I gotta have that number. That's all I need to have, okay? And then the circle that goes on -4 stays open, because there's no line. The circle on 3 gets closed in, because there is a line. And X is in the middle. It's an and problem, so I shade in the middle. I know you're going to start solving these and forget. When do I shade in the middle and when do I shade past the middle, the whole thing? That's an or problem. And problems, X has to satisfy this guy and this guy at the same time. So it's limited to just this overlapping part. If it's one or the other, then it would go everything past this or everything past this. But it's and, so it's in the middle. Okay, let's do another one. Number 2. I have 7 is less than 6x minus 5 is less than 6 plus 5x. All right, so we solved this one. And again, I'm going to separate it. So I'm going to write this one over here. 7 less than 6x minus 5. This one over here, 6x minus 5 is less than 6 plus 5x. That's a tongue twister. And I'm going to solve each. So here I'm going to get x alone, add 5. 12 is less than 6x, divide by 6. 2 is less than x. So I got this answer. Oops, you can't see that. So I got this answer, and I don't want to switch it yet because I'm going to combine it back. Now I solve this one, get rid of my smallest x. Oops, I didn't mean to mark that out. That's 1x minus 5 is less than 6. These get marked out. And then I add 5. X is less than 11. Okay, and now I join them back up. I've got one answer for each of these. So now I put them back together. X goes in the middle. And then I copy this side. So 2 is less than. And then I copy this side, less than 11. Right, so here's my answer for this and compound inequality. Draw my number line, smallest number on the left, biggest number on the right. Now you can go 3, 4, 5, 6, 7, 8, 9, 10, 11, write all your numbers on your number line. But why? When you just need these two answers graphed. So I put an open circle here, an open circle here. X is in the middle, so I shade in the middle. Done and done. Okay, last one. Let's do one more and problem. You don't have to separate them like I'm doing every time. If they're simple and they're easy enough to solve, just, solve them like we were doing earlier in the first video. But if they're more complex, this is one way you can do it. All right. 3x minus 7 is less than or equal to 4x plus 2 less than or equal to 2 times 9 plus x. All right, so we're going to separate this guy. Separate this one, separate this one. 3x minus 7 less than or equal to 4x plus 2. And 4x plus 2 less than or equal to 2 times 9 plus x. All right, easy peasy. Now I solve each of these. So here I get rid of my smallest x, minus 3x, negative 7 less than or equal to x plus 2. Minus 2 on each side, negative 9 less than or equal to x, and I'm done there. For this one, first thing I got to do is distribute. So 4x plus 2 less than or equal to 18 plus 2x. Get rid of my smallest x, so minus 2x on both sides. Minus 2 on both sides, 2x is less than or equal to 16. And then divide both sides by 2. X is less than or equal to 8. Okay, so once I've got an answer on both sides, then I can combine them, put x in the middle, copy this side, copy this side, and there's my answer, right? This side matches this side matches this. It makes sense. The signs are open in the same direction, smallest number on the left, biggest number on the right. Makes sense. So I graph it. Negative 9, 8. Circle shaded in because it's got the line under. circle, shade it in, cut the line under, and shade in the middle. Easy peasy. All right, those are and compound inequalities when we're solving and graphing them. Let's do a few or compound inequalities. First one, let's do negative 3p plus 1. I think I actually might have already done this one, but that's okay if I did. Or p is less than 2. Maybe I didn't. I think I did in one of the other takes I tried to do for this lesson. Tried a video. All right, first one we'll solve this side. So I need to get p by itself. So I want to get rid of this 1. Negative 3p. Bring down my sign. Negative 11 minus 1 is negative 12. And then I need to divide by negative 3 to get p by itself. But do you notice something? I'm dividing both sides of an inequality by a negative number. So what happens to my sign? My sign has to flip. Whenever you multiply or divide both sides by a negative, your sign flips, right? So then I can write, these cancel. So I got a p here. Negative 12 divided by negative 3 is positive 4. So here's this answer. Then I'm done here, right? I don't need to combine them into one thing because it's not an and problem, it's an or problem. So I can write p is greater than or equal to 4, or p is less than 2. And then when I graph it, same thing. I'm going to plot a 4. I'm going to plot a 2. Y'all ignore me. 2, 4. Hands up if you've done this already. All right, closed in circle on the 4, open circle on the 2, and it's an or problem. So it's either bigger than 4 or less than 2. And actually, I messed up because when I write my answer, I'm supposed to put the smallest number on the left, biggest number on the right. So I should have written it as p is less than 2 or p is greater than or equal to 4. This would have been the correct way. And then my numbers kind of align to the graph, right? So then you get it right. My inequality signs are pointing in different directions. That also tells me it's an or problem. And the word or is the dead giveaway. Okay, let's do another one. Let's do 3y plus 2. No, is it 2y? 2y plus 2 is less than 12. Or y minus 3 is greater than 2y. Greater than or equal to 2y. Okay, so we can solve each of these. Uh-oh, it's crooked, blurry. Y'all, I'm ready for break. Okay, get y by itself, minus 2, 2y less than 10. I don't always show my work. Sometimes I do, sometimes I don't. You shouldn't have to, but I ask you guys to show all your work right now because then you get in the habit of doing the steps. Sometimes when you first learn a new skill and you're like, oh, this is easy, and you start doing all of it in your head, it's super easy to make little simple mistakes. You know, forgetting to change a sign. If you're doing it in your head, that's easy to mess up, right? So it's easier, it's better for you and for me if you show all of your work. All right, and then we divide both sides by 2. Y is less than 5. Then we gotta solve this guy, get rid of the smallest y. Negative 3 greater than or equal to y. So we're done here. I'm just gonna flip-flop the y and the negative 3. The mouth is open towards the negative 3, so I go this way. And I write or in the middle, okay? Uh-oh, I see both inequality signs, call them mouths, both of them open the same direction, so this looks like it's going to be a special case. Oh, but you know what? Yeah, it definitely is. I need to rewrite my answer with the smallest number on the left, so I'm going to write y less than or equal to negative 3, or y is less than 5. That's the correct way. This way is not finished. Okay, so on my graph, I'm going to put the smallest number here. Oops, negative 3, biggest number here. The circle on the negative 3 is shaded in. The circle on the 5 is not. And y is either less than negative 3 or it's less than 5. So we just shade everything. You don't even have to have a shade over, a bubble over negative 3. Because it's shaded, so we just shade everything on our number line. Everything that's less than 5 is either going to solve this inequality, this left side, or this inequality, right? So you don't even need this right here, just 5 and down. Okay, last one and then we're done. Okay, this seems like a super long video. 3a plus 2 is greater than or equal to 5. Or 7 plus 3a is less than 2a plus 6. All right, so here we go. First one, I need to get a by itself, so I'm minus 2. 3a, 3. Divide both sides by 3. My sign never changes. Or solve this guy. Get rid of the smallest a. 7 plus a less than 6. Get rid of the number with a. A is less than negative 1. Okay, so I have a is greater than 1 or a is less than negative 1, right? So I need to put the smallest number here, biggest number here. A is less than negative 1 or a is greater than or equal to, 1. And then if I graph it, negative 1, 1. Open circle on negative 1, shaded circle on 1. Everything less than negative 1. Everything greater than 1. That's our regular OR inequality. Okay, let me know if you have questions.